In American primary care, the missing workforce is stunning in magnitude. The shortfall estimated to reach up to 48,000 doctors within the next dozen years. China and other countries with aging populations can expect drastic shortfalls as well. Just last month, I asked a respected colleague retiring from primary care who he would recommend as a replacement. He told me bluntly that, other than expensive concierge care practices, he could not think of anyone, even for himself. This mismatch between need and supply will only grow, and the U.S. is far from alone among developed countries in facing it. This is the AI Revolution in Medicine Revisited. I'm your host, Peter Lee. Shortly after OpenAI's GPT-4 was publicly released, Kerry Goldberg, Dr. Zach Ohani, and I published the AI Revolution in Medicine to help educate the world of healthcare and medical research about the transformative impact this new generative AI technology could have. But because we wrote the book when GPT-4 was still a secret, we had to speculate. Now, 2 years later, what did we get right and what did we get wrong? In this series, we'll talk to clinicians, patients, hospital administrators, and others to understand the reality of AI in the field and where we go from here. The book passage I read at the top is from Chapter 4, Trust But Verify, which was written by Zach. You know, it's no secret that in the US and elsewhere, shortages in medical staff and the rise of clinician burnout are affecting the quality of patient care for the worse. In our book, we predicted that generative AI would be something that might help address these issues. So in this episode, we'll delve into how individual performance gains that our previous guests have described might affect the healthcare workforce as a whole. And on the patient side, we'll look into the influence of generative AI on the consumerization of healthcare. Now, since all of this consumes such a huge fraction of the overall economy, we'll also get into what a general-purpose technology as disruptive as generative AI might mean in the context of labor markets and beyond. To help us do that, I'm pleased to welcome Ethan Mollick and Azim Azhar. Ethan Mollick is the Ralph J. Roberts Distinguished Faculty Scholar, a Rowan Fellow, and an Associate Professor at the Wharton School of the University of Pennsylvania. His research into the effects of AI on work, entrepreneurship, and education is applied by organizations around the world, leading him to be named one of Time Magazine's most influential people in AI for 2024. He's also the author of the New York Times bestselling book, Co-Intelligence. Azim Azhar is an author, founder, investor, and one of the most thoughtful and influential voices on the interplay between disruptive emerging technologies and business and society. In his best-selling book, The Exponential Age, and in his highly regarded newsletter and podcast, Exponential View, he explores how technologies like AI are reshaping everything from healthcare to geopolitics. Ethan and Azim are two leading thinkers on the ways that disruptive technologies, and especially AI, affect our work, our jobs, our business enterprises, and whole industries. As economists, they're trying to work out whether we are in the midst of an economic revolution as profound as the shift from an agrarian to an industrial society. Here's my interview with Ethan Mollick. Ethan, welcome.
So happy to be here. Thank you.
I described you as a professor at Wharton, which I think most of the people who listen to this podcast series knows of as an elite business school. So it might surprise some people that you study AI. And beyond that, that I would seek you out to talk about AI in medicine. So to get started, how and why did it happen that you become one of the leading experts on AI?
It's actually an interesting story. I've been AI adjacent my whole career. When I was in my PhD at MIT, I worked with Marvin Minsky and the MIT Media Lab's AI group, but I was never the technical AI guy. I was the person who was trying to explain AI to everybody else who didn't understand it. And then I became very interested in how do you train and teach? And AI was always a part of that. I was building games for teaching tools that were used at hospitals and elsewhere, simulations. So when LLMs burst into the scene, I had already been using them. and had a good sense of what they could do. And between that and kind of being practically oriented and getting some of the first research projects underway, especially under education and AI and performance, I became sort of a go-to person in the field. And once you're in a field where nobody knows what's going on, and we're all making it up as we go along, I thought it's funny that you led with the idea that you have a couple-month head start for GPT-4, right? Like that's all we have at this point is a few-month head start. So being a few months ahead is good enough to be an expert at this point. Whether it should be or not is a different question.
Well, if I understand correctly, leading AI companies like OpenAI, Anthropic, and others have now sought you out as someone who should get early access to really start to do early assessments and gauge early reactions. How has that been?
So, I mean, I think the bigger picture is less about me than about two things that tell us about the state of AI right now. One, nobody really knows what's going on, right? So in a lot of ways, if it wasn't for your work, Peter, like I don't think people would be thinking about medicine as much because these systems weren't built for medicine. They weren't built to change education. They weren't built to write memos. They weren't built to do any of these things. They weren't really built to do anything that in particular. It turns out they're just good at many things. And to the extent that the labs work on them, they care about their coding ability above everything else, and maybe math and science secondarily. They don't think about the fact that it expresses high empathy. They don't think about its accuracy in diagnosis or where it's inaccurate. They don't think about how it's changing education forever. So one part of this is the fact that they go to my Twitter feed or ask me for advice is an indicator of where they are too, which is they're not thinking about this. And the fact that a few-month head start continues to give you a lead tells you that we are at the very cutting edge. These labs aren't sitting on projects for 2 years and then releasing them. Months after a product is complete or sooner, it's out the door. Like there's very little delay. So we're kind of all in the same boat here, which is a very unusual space for a new technology.
And you know, I explained that you're at Wharton. Are you an odd fit as a faculty member of Wharton, or is this a trend now even in business schools that AI experts are becoming key members of the faculty?
I mean, it's a little of both, right? It's faculty, so everybody does everything. I'm a professor of innovation entrepreneurship. I've launched startups before, and working on that in education means I think about how do organizations redesign themselves? How do they take advantage of these kind of problems? So medicine's always been very central to that, right? A lot of people in my MBA class have been MDs, either switching, careers or else looking to advance from being sort of individual contributors to running teams. So I don't think that that's that bad a fit. But I also think this is general purpose technology. It's going to touch everything. The focus on this is medicine, but Microsoft does far more than medicine, right? There's transformation happening in literally every field in every country. This is a widespread effect. So I don't think we should be surprised that business schools matter on this because we care about management. There's a long tradition of management and medicine going together. There's actually a great academic paper that shows that teaching hospitals that also have MBA programs associated with them have higher management scores and perform better. So I think that these are not as foreign concepts, especially as medicine continues to get more complicated.
Yeah. Well, in fact, I want to dive a little deeper on these issues of management, of entrepreneurship, education. But before doing that, if I could just stay focused on you, there is always something interesting to hear from people about their first encounters with AI. And throughout this entire series, I've been doing that both pre-generative AI and post-generative AI. So you sort of hinted at the pre-generative AI. You were in Minsky's lab. Can you say a little bit more about that early encounter, and then tell us about your first encounters with generative AI?
Yeah, that's a great question. So first of all, when I was at the Media Lab, that was pre the current boom in sort of even in the old school machine learning kind of space. So there was a lot of potential directions to head in. This was while I was there were projects underway, for example, to record every interaction small children had. One of the professors was recording everything their baby interacted with, and I hoped that maybe that would give them a hint about how to build an AI system. There was a bunch of projects underway that were about labeling every concept and how they related to other concepts. So it was very much Wild West of how do we make an AI work, which has been this repeated problem in AI, which is what is this thing? And the fact that it was just brute force over the corpus of all human knowledge turns out to be a little bit of it's a miracle and a little bit of a disappointment in some ways compared to how elaborate some of this was. I think that was sort of my first encounters in sort of the intellectual way. The generative AI encounters actually started with the original sort of GPT-3 or earlier versions, and it was actually game based. So I played games like AI Dungeon, and as an educator, I realized, oh my gosh, this stuff can write essays at a fourth grade level. That's really going to change the way like middle school works, was my thinking at the time. And I was posting about that back in 2021, that this is a big deal. But I think everybody was taken surprise, including the AI companies themselves, by ChatGPT, by GPT 3.5. The difference in degree turned out to be a difference in kind.
Yeah, if I think back, even with GPT-3, and certainly this was the case with GPT-2, it was, at least from where I was sitting, it was hard to get people to really take this seriously and pay attention.
Yes.
It's remarkable within Microsoft. I think a turning point was the use of GPT-3 to do code completions. And that was actually productized as GitHub Copilot, the very first version. That, I think, is where there was widespread belief. But, in a way, I think there is, even for me early on, a sense of denial and skepticism. Did you have those initially at any point?
Yeah, I mean, and it still happens today, right? Like, this is a weird technology. The original denial and skepticism was they couldn't see where this was going. It didn't seem like a miracle because, of course computers can complete code for you. Like, what else are they supposed to do? Of course computers can give you answers to questions and write fun things. So this difference of moving into a world of generative AI, I think a lot of people just thought that's what computers could do. So it made the conversations a little weird. But even today, faced with these, with very strong reasoner models that operate at the level of PhD students, I think a lot of people have issues with it, right? I mean, first of all, they seem intuitive to use, but they're not always intuitive to use, because the first use case that everyone puts AI to, it fails at because they use it like Google or some other use case. And then it's genuinely upsetting in a lot of ways. I think, I write in my book about the idea of 3 sleepless nights. That hasn't changed. Like, you have to have an intellectual crisis to some extent, and I think people do a lot to avoid having that existential angst of like, oh my God, what does it mean that a machine can apparently think like a person? So, I mean, I see resistance now, I saw resistance then. And then on top of all of that, there's the fact that the curve of the technology is quite great. I mean, the price of GPT-4 level intelligence from when, it was released has dropped 99.97% at this point. Right. Mm-hmm. I mean, I could run a GPT-4 class system basically on my phone. Microsoft's releasing things that can almost run on like it fits in almost no space, that are almost as good as the original GPT-4 models. I mean, I don't think people have a sense of how fast the trajectory is moving either.
Yeah, there's something that I think about often. There is this existential dread, or will this technology replace me? But I think the first people to feel that are researchers, people encountering this for the first time. If you were working, let's say, in Bayesian reasoning or in traditional, let's say, Gaussian mixture model based, speech recognition, you do get this feeling, oh my God, this technology has just solved the problem that I've dedicated my life to. And there is this really difficult period where you have to cope with that. And I think this is going to be spreading, in more and more walks of life. And so at what point does that sort of sense of dread hit you, if ever?
I mean, it's not even dread as much as like, Tyler Cohen wrote that it's impossible to not feel a little bit of sadness as you use these AI systems too, because like I was talking to a friend, just as the most minor example, and his talent that he was very proud of was he was very good at writing limericks for birthday cards. He'd write these limericks. Everyone was always amused by them. And now, GPT-4 and GPT-5, 4.5, they made limericks obsolete. Like, anyone can write a good limerick, right? Like, so this was a talent, and it was a little sad. Like, this thing that you cared about mattered. I mean, as academics, we're a little used to dead ends, right? And like, something hitting the lap, but like the idea that entire fields are hitting that way. Like in medicine, there's a lot of support systems that are now obsolete. And the question is how quickly you change that. In education, a lot of our techniques are obsolete. What do you do to change that? It's like the fact that this brute force technology is good enough to solve so many problems is weird, right? And it's not just the end of our research angles that matter too. Like, for example, I ran this 14-person plus multi-million-dollar effort working to build these teaching simulations. And we're very proud of them. It took years of work to build one. Now we've built a system that can build teaching simulations on demand by you talking to it with one team member. And, it's like, and you literally can create any simulation by having a discussion with the AI. I mean, there's a switch to a new form of excitement, but there is a little bit of like, this mattered to me. And now I have to change how I do things. I mean, adjustment happens. But if you haven't had that displacement, I think that's a good indicator that you haven't really faced AI yet.
Yeah, what's so interesting just listening to you is you use words like sadness, and yet I can see and hear the excitement in your voice and your body language. So, that's also kind of an interesting aspect of all of this.
Yeah, I mean, I think there is something on the other side, right? But like, I can't say that I haven't had moments where like, oh, but then there's joy and basically like also, freeing stuff up. I mean, I think about doctors or professors, right? These are jobs that bundle together lots of different tasks that you would never have put together, right? If you're a doctor, you would never have expected the same person to be good at keeping up with the research and being a good diagnostician and being a good manager and being good with people and being good with hand skills. And like, who would ever want that kind of bundle? That's not something you're all good at, right? And a lot of our stress of our job comes from the fact that we suck at some of it. And so to the extent that AI steps in for that, you kind of feel bad about some of the stuff that it's doing that you wanted to do. But it's much more uplifting to be like, I don't have to do this stuff I'm bad at anymore. I get the support to make myself good at it. And the stuff that I really care about, I can focus on more. Well, because we are at kind of a unique moment where whatever you're best at, you're still better than AI. And I think it's an ongoing question about how long that lasts. But for right now, like, you're not going to say, okay, AI replaces me entirely in my job in medicine. It's very unlikely. But you will say it replaces these 17 things I'm bad at. But I never liked that anyway. So it's a period of both excitement and a little anxiety.
Yeah, I'm going to want to get back to this question about in what ways AI may or may not replace doctors or some of what doctors and nurses and other clinicians do. But let's before that, let's get into, I think, the real meat of this conversation. In previous episodes of this podcast, we talked to clinicians and healthcare administrators and technology developers that are very rapidly injecting AI today to do various forms of workforce automation. Automatically writing a clinical encounter note, automatically filling out a referral letter or a request for prior authorization for some reimbursement to an insurance company. And so these sorts of things are intended not only to make things more efficient and lower costs, but also to reduce various forms of drudgery, cognitive burden on frontline health workers. So how do you think about the impact of AI on that aspect of workforce? And, and what would you expect will happen over the next few years in terms of impact on efficiency and costs?
So, I mean, this is a case where I think we're facing the big, bright problem in AI in a lot of ways, which is that this is at the individual level, there's lots of performance gains to be gained, right? The problem, though, is that we as individuals fit into systems, in medicine as much as anywhere else or more so, right? Which is that you could individually boost your performance, but it's also about systems that fit along with this, right? So, if you could automatically, record an encounter, if you could automatically make notes, does that change what you should be expecting for notes or the value of those notes or what they're for? How do we take what one person does and validate it across the organization and roll it out for everybody without making it a 10-year process that it feels like IT and medicine often is? So we're in this really interesting period where there's incredible amounts of individual innovation and productivity and performance improvements in this field, like very high levels of it, but not necessarily seeing that same thing translate to organizational efficiency or gains. And one of my big concerns is seeing that happen. We're seeing that in non-medical problems, the same kind of thing, which is, we've got research showing 20 to 40% performance improvements, like not uncommon to see those things. But then the organization doesn't capture it. The system doesn't capture it because the individuals are doing their own work and the systems don't have the ability to kind of learn or adapt as a result.
Where are those productivity gains going then when you get to the organizational level?
Well, they're dying for a few reasons. One is there's a tendency for individual contributors to underestimate the power of management, right? Good practices associated with good management increase happiness, decrease, issues, increase the, success rates. In the same way, about 40%, as far as we can tell, of the U.S. advantage over other companies of U.S. firms has to do with management ability. Like, management is a big deal. Organizing is a big deal. Thinking about how you coordinate is a big deal. at the individual level, when things get stuck there, right, you can't start bringing them up to how systems work together. It becomes, how do I improve? How do I deal with a doctor that has a 60% performance improvement? We don't really only have one thing in our playbook for doing that right now, which is, okay, we can fire 40% of the other doctors and still have a performance gain, which is not the answer you want to see happen. So because of that, people are hiding their use. They're actually hiding their use for lots of reasons. And it's a weird case because the people who are able to figure out best how to use these systems for a lot of use cases are actually clinicians themselves, because they're experimenting all the time. Like, they have to take those encounter notes. And if they figure out a better way to do it, they figure that out. You don't want to wait for a med tech company to figure that out and then sell that back to you when it can be done by the physicians themselves. So we're just not used to a period where everybody's innovating and where the management structure isn't in place to take advantage of that. And so we're seeing things stalled at the individual level. And people are often, especially in risk-averse organizations or organizations where there's lots of regulatory hurdles, people are so afraid of the regulatory piece that they don't even bother trying to make change.
If you are, the leader of a hospital or a clinic or a whole health system, how should you approach this? How should you be trying to extract positive success out of AI?
So I think that you need to embrace the right kind of risk, right? We don't want to put risk on our patients. Like, we don't want to put uninformed risk. But innovation involves risk to how organizations operate. They involve change. So I think part of this is embracing the idea that R&D has to happen in organizations again. What's happened over the last 20 years or so has been organizations giving that up. Partially, that's a trend to focus on what you're good at and not trying to do this other stuff. Partially, it's because it's outsourced now to software companies that, like, Salesforce tells you how to organize your sales team. Workforce tells you how to organize your organization. Consultants come in and will tell you how to make change based on the average of what other people are doing in your field. So companies and organizations and hospital systems have all started to give up their ability to create their own organizational change. And when I talk to organizations, I often say they have to have two approaches. They have to think about the crowd and the lab. So the crowd is the idea of how to empower clinicians and administrators and supporter networks to start using AI and experimenting in ethical, legal ways, and then sharing that information with each other. And the lab is, how are we doing R&D about the approach of how AI to work? Not just direct patient care, right? But also fundamentally, like, what paperwork can we cut out? How can we better explain procedures? Like, what management role can this fill? And we need to be doing active experimentation on that. We can't just wait for Microsoft to solve the problems. It has to be at the level of the organizations themselves.
So let's shift a little bit to the patient. One of the things that we see, and I think everyone is seeing, is that people are turning to chatbots like ChatGPT actually to seek healthcare information, for their own health or the health of their loved ones. And there was already, prior to all of this, a trend towards, let's call it consumerization of healthcare. So just in the business of healthcare delivery, do you think AI is going to hasten these kinds of trends, or, from the consumer's perspective?
Absolutely, right? And like, all the early data we have suggests that for most common medical problems, you should just consult AI too, right? Like, in fact, there is a real question to ask: at what point does it become unethical for doctors themselves to not ask for a second opinion from the AI because it's cheap, right? You could overrule it or whatever you want, but like, not asking seems foolish. I think the two places where there's a burning, almost, moral imperative is, let's say, I'm in Philadelphia. I'm a professor. I have access to really good healthcare through the University of Pennsylvania system. I know doctors. I'm lucky. I'm well connected. If something goes wrong, I have friends who I can talk to. I have specialists. I'm pretty well educated in this space. But for most people on the planet, they don't have access to good medical care. They don't have good health. It feels like an absolutely imperative to say, when should you use AI and when not? Are there blind spots? What are those things? And I worry that, like, to me, that would be the crash project I'd be invoking. Because I'm doing the same thing in education, which is, this system is not as good as being in a room with a great teacher who also uses AI to help you, but it's better than not getting it, to the level of education people get in many cases. Where should we be using it? How do we guide usage in the right way? Because the AI labs aren't thinking about this. We have to. So to me, there is a burning need here to understand this. And I worry that people will say, everything that's true, AI can hallucinate, AI can be biased. All of these things are absolutely true, but people are going to use it. The early indications are that it is quite useful. And unless we take the active role of saying, here's when to use it, here's when not to use it, we don't have a right to say, don't use this system. And I think, we have to be exploring that.
What do people need to understand about AI? And what should schools, universities, and so on be teaching?
Those are kind of two separate questions in a lot of
Yeah.
ways.
Hmm.
I think a lot of people want to teach AI skills. And I will tell you, as somebody who works in this space a lot, there isn't like an easy sort of AI skill. I can teach you prompt engineering in 2 to 3 classes, but every indication we have is that for most people, under most circumstances, the value of prompting, any one case is probably not that useful. A lot of the tricks are disappearing because the AI systems are just starting to use them themselves. So asking good questions, being a good manager, those, being a good thinker tend to be important. But like magic tricks around, making the AI do something because you use the right phrase used to be something that was real, but is rapidly disappearing. So I worry when people say teach AI skills, no one's been able to articulate to me, as somebody who knows AI very well and teaches classes on AI, what those AI skills everyone should learn are, right? I mean, there's value in learning a little bit how the models work. There's value in working with these systems. A lot of it's just hands-on keyboard kind of work. But like, we don't have an easy slam dunk, this is what you learn in the world of AI, because the systems are getting better. And as they get better, they get less sensitive to these prompting techniques. They get better at prompting themselves. They solve problems spontaneously and start being agentic. So it's a hard problem to ask about, like, what do you train someone on? I think getting people experience in hands and keyboards, getting them to, there's like 4 things I could teach you about AI that, and 2 of them are already starting to disappear, but like, one is be direct, like tell the AI exactly what you want. That's very helpful. Second, provide as much context as possible. That can include things like acting as a doctor, but also all the information you have. The third is give it step-by-step directions. That's becoming less important. And the fourth is good and bad examples of the kind of output you want. Those 4, that's it as far as the research telling you what to do. And the rest is building intuition.
I'm really impressed that you didn't give the answer. Well, everyone should be teaching my book, Co-Intelligence.
Oh, no, sorry. Everybody should be teaching my book, Co-Intelligence. I apologize.
Very good. It's good to chuckle about that. But actually, I can't think of a better book. Like if you were to assign a textbook in any professional education space, I think Co-Intelligence would be number 1 on my list. Are there other things that you think are essential reading?
That's a really good question. I think that a lot of things are evolving very quickly. I happen to kind of hit a sweet spot with Co-Intelligence to some degree because I talk about how I used it and I was sort of an advanced user of these systems. So it's sort of like my Twitter feed, my online newsletter. I'm just trying to kind of, in some ways, it's about trying to make people aware of what these systems can do by just showing a lot, right? Rather than picking one thing. And like, this is a general purpose technology. Let's use it for this. And like, everybody gets a light bulb for a different reason. So more than reading, it is using, and that can be Copilot or whatever your favorite tool is. But using it, voice modes help a lot. In terms of readings, I mean, I think that there is a couple good guides to understanding AI that have written blog posts. I think Tim Lee has one called Understanding AI. That's a kind of good overview of that topic that I think explains how transformers work, which can kind of give you some mental sense. I think Karpathy has some really nice videos of use that I would recommend. Like on the medical side, I think the book that you did, if you're in medicine, you should read that. I think that's very valuable. But like all we can offer are hints in some ways. Like there isn't, if you're looking for the instruction manual, I think it can be very frustrating because it's like you want the best practices and procedures laid out, and we cannot do that, right? That's not how the system like this works.
Yeah.
It's not a person, but thinking of it like a person can be helpful, right?
One of the things that has been sort of a fun project for me for the last few years is I have been a founding board member of a new medical school at Kaiser Permanente, and that medical school curriculum is being formed in this era, but it's been perplexing to understand what this means for a medical school curriculum, and maybe even more perplexing for me at least is the accrediting bodies, which are extremely important in U.S. medical schools. How accreditors should think about what's necessary here. Are there, besides the things that the kind of 4 key ideas you mentioned, if you were talking to the board of directors of the LCME accrediting body, what's the one thing you would want them to really internalize?
This is both a fast-moving and vital area. This can't be viewed like a usual change, which let's see how this works, because it's like the things that make it medical technologies hard to do, which is like unclear results, limited, expensive use cases where it rolls out slowly. So 1 or 2, advanced medical facilities get access to, proton beams or something else at multi-billions of dollars of cost, and that takes a while to diffuse out. That's not happening here. This is all happening at the same time, all at once. This is now, AI is part of medicine. I mean, there's a minor point that I'd make that actually is a really important one, which is large language models, generative AI overall, work incredibly differently than other forms of AI. So the other worry I have with some of these accreditors is they blend together algorithmic forms of AI, which medicine's been trying for a long time, decision support, algorithmic methods, like medicine more than most other places have been thinking about those issues. Generative AI, even though it uses the same underlying techniques, is a completely different beast. So like even just take the most simple thing of algorithmic aversion, which is a well understood problem in medicine, right? Which is, so you have a tool that can tell you as a radiologist, the chance of this being cancer. You don't like it, you overrule it, right? We don't find algorithmic aversion happening with LLMs in the same way. People actually enjoy using them because it's more like working with a person. The flaws are different, the approach is different. So you need to both view this as universally applicable today, which makes it urgent, but also as something that is not the same as your other form of AI. And your AI working group that is thinking about how to solve this problem is not the right people here.
I think the world has been trained because of the magic of web search to view computers as question answering machines. Ask a question, get an answer.
Yes.
Write a query, get results. And as I have interacted with medical professionals, you can see that medical professionals have that model of a machine in mind. And I think that's partly, psychologically why hallucination is so alarming, because you have a mental model of a computer as a machine that has absolutely rock-solid, perfect memory recall. But the thing that was so powerful in co-intelligence, and we tried to get at this in our book also, is that's not the sweet spot. It's this sort of deeper interaction, more of a collaboration. And I thought your use of the term co-intelligence really, just even in the title of the book, tried to capture this. When I think about education, it seems like that's the first step to get past this concept of a machine being just a question answering machine. Do you have a reaction to that idea?
I think that's very powerful. We've been trained over so many years of both using computers, but also science fiction, right? Computers are about cold logic, right? They will give you the right answer, but if you ask it what love is, they explode, right? Like that's the classic way you defeat the evil robot in Star Trek, right? Love does not compute. Instead, we have a system that makes mistakes, is warm, beats doctors in empathy in almost every controlled study on the subject, right? Like absolutely can outright you in a sonnet, but will absolutely struggle with giving you the right answer every time. And I think our mental models are just broken for this. And I think you're absolutely right. And that's part of what I thought your book does get at really well is like, this is a different thing. It's also generally applicable. Again, the model in your head should be kind of like a person, even though it isn't, right? Like there's a lot of warnings and caveats to it, but if you start from person, smart person you're talking to, your mental model will be more accurate than smart machine, even though both are flawed examples, right? So it will make mistakes, it'll make errors. The question is, what do you trust it on? What do you not trust it on? And as you get to know a model, you'll get to understand, like, I totally don't trust it for this, but I absolutely trust it for that, right?
All right. So we're getting to the end of the time we have together. And so just like to get now into something a little bit more provocative. And I get the question all the time, will AI replace doctors? What are, in medicine and other advanced knowledge work, project out 5 to 10 years. What do you think happens?
Okay, so first of all, let's acknowledge systems change much more slowly than individual use. Doctors are not individual actors, they're part of systems, right? So not just the system of a patient who may or may not want to talk to a machine instead of a person, but also legal systems and administrative systems and systems that allocate labor and systems that train people. So it's hard to imagine in 5 to 10 years, medicine being so upended that even if AI was better than doctors at every single thing doctors do, that we'd actually see as radical change in medicine as you might in other fields. I think you will see faster changes happen in consulting and law and other, coding, other spaces than medicine. But I do think that there is good reason to suspect that AI will outperform people while still having flaws, right? That's the difference. We're already seeing that for common medical questions in enough randomized controlled trials that, best doctors beat AI, but the AI beats the mean doctor, right? That's just something we should acknowledge is happening at this point. Now, will that work in your specialty? No. Will that work with all the contingent social knowledge that you have in your space? Probably not. Like, these are vignettes, right? But like, that's kind of where things are. So let's assume, right? They're asking two questions. One is, how good will AI get?
Yep.
And we don't know the answer to that question. I will tell you that your colleagues at Microsoft, and increasingly the labs, the AI labs themselves, are all saying they think of a machine smarter than a human at every intellectual task in the next 2 to 3 years. If that doesn't happen, that makes it easier to assume the future, but let's just assume that that's the case. I think medicine starts to change with the idea that people feel obligated to use this to help for everything. Your patients will be using it, and it will be your advisor and helper at the beginning phases, right? And I think that I expect people to be better at empathy. I expect better bedside manner. I expect management tasks to become easier. I think administrative burden might get lighten if we handle this the right way, or much worse if we handle it badly. Diagnostic accuracy will increase, right? And then there's a set of discovery pieces happening too, right? One of the core goals of all the AI companies is to accelerate medical research. How does that happen, and how does that affect us, is a kind of unknown question. So I think clinicians are in both the eye of the storm and surrounded by it, right? Like, they can resist AI use for longer than most other fields, but everything around them is going to be affected by it.
Well, Ethan, this has been really a fantastic conversation. And, I think in contrast to all the other conversations we've had, this one gives especially the leaders in healthcare, people actually trying to lead their organizations into the future, whether it's in education or in delivery, a lot to think about. So really appreciate you joining.
Thank you.
I'm a computing researcher who works with people who are right in the middle of today's bleeding edge developments in AI. And because of that, I often lose sight of how to talk to a broader audience about what it's all about. And so I think one of Ethan's superpowers is that he has this knack for explaining complex topics in AI in a really accessible way, getting right to the most important points without making it so simple as to be useless. That's why I rarely miss an opportunity to read up on his latest work. One of the first things I learned from Ethan is the intuition that you can sort of think of AI as a very knowledgeable intern. In other words, think of it as a persona that you can interact with, but you also need to be a manager for it and to always assess the work that it does. In our discussion, Ethan went further to stress that there is, because of that, a serious education gap. Over the last decade or two, we've all been trained, mainly by search engines, to think of computers as question answering machines. In medicine, in fact, there's a question answering application that is really popular called UpToDate. Doctors use it all the time. But generative AI systems like ChatGPT are different. There's therefore a challenge in how to break out of the old-fashioned mindset of search to get the full value out of generative AI. The other big takeaway for me was that Ethan pointed out, while it's easy to see productivity gains from AI at the individual level, those same gains, at least today, don't often translate automatically to organization-wide or system-wide gains. And one, of course, has to conclude that it takes more than just making individuals more productive. The whole system also has to adjust to the realities of AI. Here's now my interview with Azim Azhar. Azim, welcome.
Peter, thank you so much for having me.
I think you're extremely well known in the world, but still some of the listeners of this podcast series might not have encountered you before. And so one of the ways I like to ask people to introduce themselves is, how do you explain to your parents what you do every day?
Well, I'm very lucky in that way because my mother was the person who got me into computers more than 40 years ago. And I still have that first computer, a ZX81 with a Z80 chip.
Oh, wow.
To this day, it sits in my study, all 7,500 transistors and Bakelite plastic that it is. And my parents were both economists, and economics is deeply connected with technology in some sense. And I grew up in the late 70s and the early 80s, and that was a time of tremendous optimism around technology. It was space operas, science fiction, robots, and of course the personal computer, and Bill Gates and Steve Jobs. So that's where I started. And so in a way, my mother and my dad, who passed away a few years ago, had always known me as someone who was fiddling with computers, but also thinking about economics and society. And so in a way, it's easier to explain to them because they're the ones who nurtured the environment that allowed me to research technology and AI and think about what it means to firms and to the economy at large.
I always like to understand the origin story. And what I mean by that is, what was your first encounter with generative AI, and what was that like? What did you go through?
The first real moment was when Midjourney and Stable Diffusion emerged in that summer of 2022. I'd been away on vacation and I came back, and I'd been off grid, in fact, and the world had really changed. Now, I'd been aware of GPT-3 and GPT-2, which played around with them and with BERT, the original Transformer paper about 7 or 8 years ago. But it was the moment where I could talk to my computer and it could produce these images and it could be refined in natural language that really made me think we've crossed into a new domain. We've gone from AI being highly discriminative to AI that's able to explore the world in particular ways. And then it was a few months later that ChatGPT came out, November the 30th. And I think it was the next day or the day after that I said to my team, everyone has to use this, and we have to meet every morning and discuss how we experimented the day before. And we did that for 3 or 4 months. And it was really clear to me in that interface at that point that we'd absolutely passed some kind of threshold.
And who's the we that you were experimenting with?
So I have a team of 4 who support me. They're mostly researchers of different types. I mean, it's almost like one of those jokes. I have a sociologist, an economist, and an astrophysicist, and they walk into the bar or they walk into our virtual team room, and we try to solve problems.
Well, so let's get now into brass tacks here. And I think I want to start maybe just with an exploration of the economics of all this and economic realities, because I think in a lot of your work, for example, in your book, you look pretty deeply at how automation generally and AI specifically are transforming certain sectors like finance, manufacturing, and you have a really kind of insightful focus on what this means for productivity and which ways efficiencies are found, and then you sort of balance that with risks, things that can and do go wrong. And so, as you take that background and looking at all these other sectors, in what ways are the same patterns playing out or likely to play out in healthcare and medicine?
I'm sure we will see really remarkable parallels, but also new things going on. I mean, medicine has a particular quality compared to other sectors in the sense that it's highly regulated, market structure is very different country to country, and it's an incredibly broad field. I mean, you just think about taking a Tylenol and going through laparoscopic surgery, having an MRI and seeing a physio. I mean, this is all medicine. I mean, it's hard to imagine a sector that is more broad than that. So I think we can start to break it down. And where we're seeing things with generative AI will be that the sort of softest entry point, which is the medical scribing. And I'm sure many of us have been with clinicians who have a medical scribe running alongside. They're all on Surface Pros, I noticed, right? They're on the tablet computers and they're scribing away. And what that's doing is, in the words of my friend Eric Topol, it's giving the clinician time back, right? They have time back from days that are extremely busy and full of administrative overload. So I think you can obviously do a great deal with reducing that overload. And within my team, we have a view, which is if you do something 5 times in a week, you should be writing an automation for it. And if you're a doctor, you're probably reviewing your notes, writing the prescriptions and so on several times a day. So those are things that can clearly be automated and the human can be in the loop. But I think there are so many other ways just within the clinic that things can help. So one of my friends, my friend from my junior school, I've known him since I was 9, is an oncologist who's also deeply into machine learning, and he's in Cambridge in the UK. And he built with Microsoft Research a suite of imaging AI tools from his own discipline, which they then open sourced. So that's another way that you have an impact, which is that you actually enable the generalist, specialist, polymath, whatever they are in health systems to be able to get this technology, to tune it to their requirements, to use it to encourage some grassroots adoption in a system that's often been very, very heavily centralized. And then I think there are some other things that are going on that I find really, really exciting. So one is the consumerization of healthcare. So I have one of those sleep tracking rings, the Oura. That is building a data stream that we'll be able to apply more and more AI to. I mean, right now it's applying traditional, I suspect, machine learning, but you can imagine that as we start to get more data, we start to get more used to measuring ourselves, we create this sort of pot of a personal asset that we can turn AI to. And there's still another category. And that other category is what are the completely novel ways in which we can enable patient care and patient pathway. And there's a fantastic startup in the UK called Neko Health, which, I mean, does sort of physical MRI scans and blood tests and so on. It's hard to imagine Neko existing without the sort of advanced data, machine learning, AI that we've seen emerge over the last decade. So, I mean, I think that there are so many ways in which the temperature is slowly being turned up to encourage a phase change within the healthcare sector. And last but not least, I do think that these tools can also be very, very supportive of a clinician's life cycle. I think we, as patients, we're a bit, I don't know if we're as grateful as we should be for our clinicians who are putting in 90-hour weeks. But you can imagine a world where AI is able to support not just the clinician's workload, but also their sense of stress, their sense of burnout. So just in those 5 areas, Peter, I sort of imagine we could start to fundamentally transform over the course of many years, of course, the way in which people think about their health and their interactions with healthcare systems.
I love how you break that down. And I want to press on a couple of things. You also touched on the fact that medicine is, at least in most of the world, is a highly regulated industry. I guess finance is the same way, but they also feel different because like the finance sector has to be very responsive to consumers, and consumers are sensitive to an abundance of choice. They're sensitive to price. Is there something unique about medicine besides being regulated?
I mean, there absolutely is. And in finance as well, you have much clearer end states. So if you're not in the consumer space, but you're in the asset management space, you have to essentially deliver returns against the volatility or risk boundary, right? That's what you have to go out and do. And I think if you're in the consumer industry, you can come back to very, very clear measures, net promoter score being a very good example. in the case of medicine and healthcare, it is much more complicated because as far as the clinician is concerned, people are individuals, and we have our own paths and our own responses. If we didn't, there would never be a need for a differential diagnosis. There'd never be a need for, let's try azithromycin first, and then if that doesn't work, we'll go to vancomycin. Right. Whatever it happens to be, you would just know. But ultimately, people are quite different. The symptoms they're showing are quite different, and also their compliance is really, really different. I had a back problem that had to be dealt with by physio and extremely boring exercises 4 times a week, but I was ruthless in complying, and my physio was incredibly surprised. He was saying, well, no one ever does this. And I said, well, the thing is that I kind of just want to get this thing to go away. And I think that's why medicine is and healthcare is so different and more complex. But I also think that's why AI can be really, really helpful. I mean, we didn't talk about AI in its ability to potentially do this, which is to extend the clinician's presence throughout the week.
Right.
The idea that maybe some part of what the clinician would do if you could talk to them on Wednesday, Thursday, and Friday could be delivered through an app or a chatbot, just as a way of encouraging the compliance, which is often, especially with older patients, one reason why conditions linger on for longer.
Just staying on the regulatory thing, as I've thought about this, the one regulated sector that I think seems to have some parallels to healthcare is energy delivery, energy distribution. Because like healthcare, as a consumer, I don't have choice in who delivers electricity to my house. And even though I care about it being cheap, or at least not being overcharged, I don't have an abundance of choice. I can't do price comparisons. And there's something about that, just speaking as a consumer of both energy and a consumer of healthcare, that feels similar. Whereas other regulated industries, somehow as a consumer, I feel like I have a lot more direct influence and power. Does that make any sense to someone like you, who's really much more expert in how economic systems work?
I mean, in a sense, one part of that is very, very true. You have a limited panel of energy providers you can go to, and in the US, there may be places where you have no choice. I think the area where it's slightly different is that as a consumer, or a patient, you can actually make meaningful choices and changes yourself using these technologies. And people used to joke about, asking Dr. Google, but Dr. Google is not terrible, particularly if you go to WebMD.
Right.
When I look at long range change, many of the regulations that exist around healthcare delivery were formed at a point before people had access to good quality information at the touch of their fingertips, or when education levels in general were much, much lower. And many regulations existed because of the incumbent power of particular professional sectors. I'll give you an example from the United Kingdom. So I have had asthma all of my life. That means I've been taking my inhaler, Ventolin, and maybe a steroid inhaler for nearly 50 years. That means that I know, actually, I've got more experience, and I, in some sense, know more about it than a general practitioner.
Yeah.
And until a few years ago, I would have to go to a general practitioner to get this drug that I've been taking for 5 decades, and there they are, age 30 or whatever it is. And a few years ago, the regulations changed, and now pharmacies can, or pharmacists can prescribe those types of drugs under certain conditions directly.
Right.
That was not to do with technology. That was to do with incumbent lock-in. And so when we look at the medical industry and the healthcare space, there are some parallels with energy, but there are a few little things that the ability that the consumer has to put in some effort to learn about their condition, but also the fact that some of the regulations that exist just exist because certain professions are powerful.
Yeah. One last question while we're still on economics. There seems to be a conundrum about productivity and efficiency in healthcare delivery, because I've never encountered a doctor or a nurse that wants to be able to handle even more patients than they're doing on a daily basis. And so, if productivity means simply, well, your rounds can now handle 16 patients instead of 8 patients, that doesn't seem necessarily to be a desirable thing. So how can we, or should we, be thinking about efficiency and productivity, since obviously costs are, in most of the developed world, are a huge problem?
Yes, and when you described doubling the number of patients on the round, I imagined you buying them all roller skates so they could just whiz around the hospital faster and faster than ever before. We can learn from what happened with the introduction of electricity. Electricity emerged at the end of the 19th century, around the same time that cars were emerging as a product, and car makers were very small and very artisanal. And in the early 1900s, some really smart car makers figured out that electricity was going to be important. And they bought into this technology by putting pendant lights in their workshops so they could visit more patients, right? They could effectively spend more hours working. And that was a productivity enhancement, and it was noticeable. But of course, electricity fundamentally changed the productivity by orders of magnitude of people who made cars, starting with Henry Ford, because he was able to reorganize his factories around the electrical delivery of power, and to therefore have the moving assembly line, which 10x'd the productivity of that system. So when we think about how AI will affect the clinician, the nurse, the doctor, it's much easier for us to imagine it as the pendant light that just has them working later than it is to imagine a reconceptualization of the relationship between the clinician and the people they care for. And I'm not sure, I don't think anybody knows what that looks like, but I do think that there will be a way that this changes, and you can see that scale out factor. And it may be, Peter, that what we end up doing is we end up saying, okay, because we have these brilliant AIs, there's a lower level of training and cost and expense that's required for a broader range of conditions that need treating. And that expands the market, right? That expands the market hugely. It's what has happened in the market for taxis or ride sharing. The introduction of Uber and the GPS system has meant many more people now earn their living driving people around in their cars. And at least in London, you had to be reasonably highly trained to do that. So I can see a reorganization is possible. Of course, entrenched interests, the economic flow, and there are many entrenched interests, particularly in the US, between the health systems and the professional bodies that might slow things down. But I think a reimagining is possible. And if I may, I'll give you one example of that, which is if you go to countries outside of the US where there are many more sick people per doctor, they have incentives to change the way they deliver their healthcare. And well before there was AI of this quality around, there was a few cases of health systems in India. Aravind Eye Care was one, and Narayana Hridalia was another. And in the latter, they were a cardiac care unit where you couldn't get enough heart surgeons. So specially trained nurses would operate under the supervision of a single doc surgeon who would supervise many in parallel. So there are ways of increasing the quality of care, reducing the cost, but it does require a systems change, and we can't expect a single bright algorithm to do it on its own.
Yeah, really, really interesting. So now let's get into the regulation, and let me start with this question. There are several startup companies I'm aware of that are pushing on, I think, a near-term future possibility that a medical AI for consumer might be allowed, say, to prescribe a medication for you, something that would normally require a doctor or a pharmacist, that is certified in some way, licensed to do. Do you think we'll get to a point where, for certain regulated activities, humans are more or less cut out of the loop?
Well, humans will have been in the loop because they would have provided the training data, they would have done the oversight, the quality control, but to your question in general, would we delegate an important decision entirely to a tested set of algorithms? I'm sure we will. We already do that. I delegate less important decisions like what time should I leave for the airport to Waze. I delegate more important decisions to the automated braking in my car. We will do this at certain levels of risk and threshold. If I come back to my example of prescribing Ventolin, it's really unclear to me that the prescription of Ventolin, this incredibly benign bronchodilator that is only used by people who've been through the asthma process, needs to be prescribed by someone who's gone through 10 years or 12 years of medical training, and why that couldn't be prescribed by an algorithm or an AI system. So I absolutely think that will be the case, and could be the case. I can't really see what the objections are, and the real issue is, where do you draw the line of where you say, listen, this is too important, or the cost is too great, or the side effects are too high, and therefore this is a point at which we want to have some human taking personal responsibility, having a liability framework in place, having a sense that there is a person with legal agency who signed off on this decision. And that line, I suspect, will start fairly low. And what we'd expect to see would be that would rise progressively over time.
What you just said, that scenario of your personal asthma medication, is really interesting, because your personal AI might have the benefit of 50 years of your own experience with that medication. So in a way, there is at least the data potential for, let's say, the next prescription to be more personalized and more tailored specifically for you.
Well, let's dig into this, because I think this is super interesting, and we can look at how things have changed. So 15 years ago, if I had a bad asthma attack, which I might have once a year, I would have needed to go and see my general physician. In the UK, it's very difficult to get an appointment. I would have had to see someone privately who didn't know me at all, because I've just walked in off the street. And I would explain my situation. It would take me half a day, productivity lost. I've been miserable for a couple of days with severe wheezing. Then a few years ago, the system changed, and a protocol changed. And now I have a thing called a rescue pack, which includes prednisolone, steroids. It includes something else I've just forgotten, and an antibiotic in case I get an upper respiratory tract infection. And I have an algorithm. It's called a protocol. It's printed out. It's a flowchart. I answer various questions, and then I say, I'm going to prescribe this to myself. And, UK doctors don't prescribe prednisolone, or prednisone, as you may call it in the US, at the drop of a hat, right? It's a powerful steroid. I can self-administer, and I can now get that repeat prescription without seeing a physician a couple of times a year. And the algorithm, the AI, it's obviously been done in PowerPoint naturally, and it's a bunch of arrows. I mean, surely an AI system is going to be more sophisticated, more nuanced, and give me more assurance that I'm making the right decision around something like that.
Yeah. Well, at a minimum, the AI should be able to make that PowerPoint.
Thank God for clipping. Yes.
So, I think in our book, we we had a lot of certainty about most of the things we've discussed here, but one chapter where I felt we really sort of ran out of ideas, frankly, was on regulation. Mm-hmm. And, what we ended up doing for that chapter is, I can't remember if it was Carrie's or Zach's idea, but we asked GPT-4 to have a conversation, a debate with itself about regulation, and we made some minor commentary on that. And really, I think we took that approach because we just didn't have much to offer. By the way, in our defense, I don't think anyone else had any better ideas anyway.
Right.
And so now, 2 years later, do we have better ideas about the need for regulation, the frameworks around which those regulations should be developed, and what should this look like?
So regulation is going to be, in some cases, very helpful because it provides certainty for the clinician that they're doing the right thing, that they are still insured for what they're doing, and it provides some degree of confidence for the patient. And we need to make sure that the claims that are made stand up to quite rigorous levels, where ideally there are RCTs and there are the classic set of processes you go through. You do also want to be able to experiment. And so the question is, as a regulator, how can you enable conditions for there to be experimentation? And what is experimentation? Experimentation is learning, so that every element of the system can learn from this experience. And so finding that space where there can be a bit of experimentation, I think becomes very, very important. And a lot of this is about experience. So I think the first digital therapeutics have received FDA approval, which means there are now people within the FDA who understand how you go about running an approvals process for that and what that ends up looking like. And of course, what we're very good at doing in this sort of modern, hyper-connected world is we can share that expertise, that knowledge, that experience very, very quickly. So you go from 1 approval a year to 100 approvals a year to 1,000 approvals a year. So we will then actually, I suspect, need to think about what is it to approve digital therapeutics, because unlike big biological molecules, we can generate these digital therapeutics at the rate of knots. Every road in Hayes Valley in San Francisco, right, is chewing out new startups who will want to do things like this. So then I think about, what does it mean to get approved if indeed it gets approved? But we can also go really far with things that don't require approval. And I come back to my sleep tracking ring. So I've been wearing this for a few years, and when I go and see my doctor, or I have my annual checkup, one of the first things that he asks is, how have I been sleeping? And in fact, I even sync my sleep tracking data to their medical record system. So he's hearing what I'm saying, but he's actually pulling up the real data going, this patient's lying to me again. Of course, I'm very truthful with my doctor, as we should all be.
Actually, that brings up a point that, consumer-facing health AI has to deal with pop science, bad science, weird stuff that you hear on Reddit. And because one of the things that consumers want to know always is, what's the truth? What can I rely on? And I think that somehow feels different than an AI that you actually put in the hands of, let's say, a licensed practitioner. And so the regulatory issues seem very, very different for these two cases somehow.
I agree, they're very different. And I think for a lot of areas, you will want to build AI systems that are first and foremost for the clinician, even if they have patient extensions, that idea that the clinician can still be with the patient during the week. And you'll do that anyway because you need the data, and you also need a little bit of a liability shield to have like a sensible person who's been trained around that. And I think that's going to be a very important pathway for many AI medical crossovers. You're going to go through through the clinician. But I also do recognize what you say about the kind of kooky quackery that exists on Reddit. Although on creatine, Reddit may yet prove to be have been right.
That's right. Yeah, absolutely.
Sometimes it's right, and I think that it serves a really good role as a field of extreme experimentation. So if you're somebody who makes a continuous glucose monitor, traditionally given to diabetics, but now lots of people will wear them and sports people will wear them, you probably gathered a lot of extreme tail distribution data by reading the Reddit/biohackers for the last few years, where people were doing things that you would never want them to really do with the CGM. And so I think we shouldn't, understate how important that petri dish can be for helping us learn what could happen next.
Oh, I think it's absolutely going to be essential and a bigger thing in the future. So I think I just want to close here then with one last question. And I always try to be a little bit provocative with this. And so as you look ahead to what doctors and nurses and patients might be doing 2 years from now, 5 years from now, 10 years from now, do you have any kind of firm predictions?
I'm going to push the boat out, and I'm going to go further out than closer in.
Okay.
So as patients, we will have many, many more touch points and interaction with our biomarkers and our health. We'll be reading how well we feel through an array of things. And some of them will be wearing directly, like sleep trackers and watches. And so we'll have a better sense of what's happening in our lives. It's like the moment you go from paper bank statements that arrive every month to being able to see your account in real time. And I suspect we'll still have interactions with clinicians, because societies that get richer see doctors more. Societies that get older see doctors more. And we're going to be doing both of those over the coming 10 years. But there will be a sense, I think, of continuous health engagement, not in an overbearing way, but just in a sense that we know it's there, we can check in with it. It's likely to be data that is compiled on our behalf somewhere centrally and delivered through a user experience that reinforces agency rather than anxiety. And we're learning how to do that slowly. I don't think the health apps on our phones and devices have yet quite got that right. And that could help us personalize problems before they arise. And again, I use my experience for a few things that I've tracked really, really well. And I know from my data and from how I'm feeling when I'm on the verge of one of those severe asthma attacks that hits me once a year, and I can take a little bit of preemptive measure. So I think that will become progressively more common, and that sense that we will know our baselines. I mean, when you think about being an athlete, which is something I think about, but I could never ever do. But what happens is you start with your detailed baselines, and that's what your health coach looks at every 3 or 4 months.
Yeah.
For most of us, we have no idea of our baselines. We get our blood pressure measured once a year. We will have baselines, and that will help us on an ongoing basis to better understand and be in control of our health. And then if the product designers get it right, it will be done in a way that doesn't feel invasive, but it'll be done in a way that feels enabling. We'll still be engaging with clinicians augmented by AI systems more and more, because they will also have gone up the stack. They won't be spending their time on just take 2 Tylenol and have a lie down type of engagements, because that will be dealt with earlier on in the system. And so we will be there in a very, very different set of relationships, and they will feel that they have different ways of looking after our health.
Azim, it's so comforting to hear such a wonderfully optimistic picture of the future of healthcare, and I actually agree with everything you said. Let me just thank you again for joining this conversation. I think it's been really fascinating, and I think somehow the systemic issues that you tend to just see with such clarity, I think are going to be the most kind of profound drivers of change for the future. So thank you so much.
Well, thank you. It's been my pleasure, Peter. Thank you.
I always think of Azim as a systems thinker. He's always able to take the experiences of new technologies at an individual level and then project out to what this could mean for whole organizations and whole societies. In our conversation, I felt that Azim really connected some of what we learned in a previous episode, for example, from Chrissy Farr on the evolving consumerization of healthcare, to the broader workforce and economic impacts that we heard about from Ethan Mollick. Azim's personal story about managing his asthma was also a great example. He imagines a future, as do I, where personal AI might assist and remember decades of personal experience with a condition like asthma, and thereby know more than any human being could possibly know in a deeply personalized and effective way, leading to better care. Azim's relentless optimism about our AI future was also so heartening to hear. Both of these conversations leave me really optimistic about the future of AI in medicine. At the same time, it is pretty sobering to realize just how much we'll all need to change in pretty fundamental and maybe even in radical ways. I think a big insight I got from these conversations is how we interact with machines is going to have to be altered not only at the individual level, but at the company level and maybe even at the societal level. Since my conversation with Ethan and Azim, there have been some pretty important developments that speak directly to this. Just last week at Build, which is Microsoft's yearly developer conference, we announced a slew of AI agent technologies. Our CEO, Satya Nadella, in fact, started his keynote by going online in a GitHub developer environment and then assigning a coding task to an AI agent, basically treating that AI as a full-fledged member of a development team. Other agents, for example, a meeting facilitator, a data analyst, a business researcher, a travel agent, and more were also shown during the conference. But pertinent to healthcare specifically, what really blew me away was the demonstration of a healthcare orchestrator agent. And the specific thing here was in Stanford's Cancer Treatment Center, when they are trying to decide on potentially experimental treatments for cancer patients, they convene a meeting of experts. That is typically called a tumor board. And so this AI healthcare orchestrator agent actually participated as a full-fledged member of a tumor board meeting to help bring data together, make sure that the latest medical knowledge was brought to bear, and to assist in the decision-making around a patient's cancer treatment. It was pretty amazing. A big thank you again to Ethan and Azim for sharing their knowledge and understanding of the dynamics between AI and society more broadly. And to our listeners, thank you for joining us. I'm really excited for the upcoming episodes, including discussions on medical students' experiences with AI and AI's influence on the operation of health systems and public health departments. We hope you'll continue to tune in. Until next time.